Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good day. So now we proceed to our next part for chapter 1. Okay, so we have looked into how the Gaussian matrix Gaussian elimination can be used to help us to reduce the complexity of the equation, and then we also have seen how the definition of row echelon and what is the basic and free variables, so and so forth, and then how we can also use Gaussian elimination to get an inverse matrix. Okay, so now in this part we will look into more approach on how to solve the linear equation, on how to get the x values. So okay, there, if you notice the equations, the matrix form is AXB. Okay, so to get the x value, basically we can also actually calculate the inverse of A, and then we can multiply it with B. However, this approach can only be used if the A is square and invertible. Okay, which in most cases or in real life problem, it does not happen. Okay, so this will be the next approach. Okay, the second approach. The first one we have looked through it in the previous video, right? So the second approach is this one. We are using the inverse matrix. There are also what we call as Morse-Penrose pseudo-inverse. Okay, it's still related to the inverse matrices, but this one is with a more long name, Morse-Penrose pseudo-inverse, which in this case we are actually manipulating the inverse. Okay, remember, if we multiply the transpose A with the A, transpose A, we will get itself, right? The transpose A, we multiply with matrix A, we will get A. Okay, so in this case, okay, so what we do is from here, from this form, from this form AX equal to B, we modify the A into A transpose A. Alright? Okay? And this is, okay, A transpose A times A is equivalent to A and then the X. The X equal to B, we remain it as it is. So, and if you notice, this part is equivalent to B. So that's why we can rewrite the second form here to be A transform times B. Okay, so from here, we can get the X by finding the inverse of transpose A multiply with A, and then we multiply it with its transpose again and B. Okay, so from here we can get this one. Yes. Alright. Okay. The disadvantage of the third approach here is time consuming. It requires a lot of time to compute, because if you can see, we need to calculate this, and then we need to calculate this, and then we need to multiply again, and so many computations. Okay, so moreover, for reasons of numerical precision, it is generally not recommended to compute the inverse or pseudo-inverse. In the following, we will therefore briefly discuss alternative approach to solve system of linear equations. Okay, so Gaussian elimination again play an important role when checking determinants, checking whether a set of vector is linearly independent, computing the inverse, and computing the rank, and determine the basis. Gaussian elimination is an intuitive and constructive way to solve a system of linear with thousands of variables. However, for system with millions of variables, it is impractical as it is required a number of arithmetic operations scales cubically in the number of simultaneous equation. Okay, in practice, system of linear are solved indirectly, either by stationary iterative method. Okay, this is the fourth approach. Which we call as stationary iterative methods, such as Richard, Jacobi method, Gauss-Seidel, and the successive over-realization method or Kirchhoff subspace method, such as conjugate gradients, generally minimal residual, or biconjugate gradients. So this is the fifth approach to solve the linear equation. So this is an example here. So let x star be a solution of ax equal to b. The key idea of this iterative method is to set up an iteration of this form. Then you will calculate the error, okay, the residual error in every iteration and converge this equation to be near to this one. The residual error need to be at least approximate to 0 or 0. Okay, if you get the error approximately 0, meaning that the solution that you get is close to the whatever you want to have, the aim here. Okay, then in the next chapter we will look into the norm operation. Okay, all right. So next video, I will briefly explain about the vector space. Thank you.